Welcome to this explainer. Today, we're diving into math curriculum design, but we're going to look at it through a really fascinating lens. Basically, we're going to treat it like we're constructing a massive skyscraper. Because before you can build this impressive advanced mathematical high-rise, you absolutely have to pour a solid, unshakable foundation first. So, we're going to explore exactly how educators bridge that gap between essential middle school math and advanced high school concepts, making sure the structural integrity holds up every single step of the way.
Here is the blueprint we'll be following today. 1. The Grade 7 Foundation. 2. Mastering proportional relationships. 3. Defining the math boundary. 4. Algebra 1 enrichment units. And finally, 5. Advanced functions and data.
Section 1. The Grade 7 Foundation. Okay, so while accelerated tracks might be really tempted to just rush straight into things like linear functions and scale drawings, the source material emphasizes that we actually can't do that. Grade 7 students desperately need a direct bridge first. And this bridge? It's built entirely out of ratios, rates, unit rates, and percentages. It's really about setting up those core learning goals, grounding the math in the real world before we start throwing complex algebra at them. And the absolute cornerstone of this whole Grade 7 foundation is the proportional relationship. Put simply, it just means one quantity is a constant multiple of another. We usually write it as the equation y equals kx. Visually, if you graph it, it's a perfectly straight line passing directly through the origin. And that k in the equation, that is your unit rate. It acts as the constant of proportionality, and honestly, it's the anchor for literally everything that follows.
Section 2. Mastering proportional relationships. Let's see how this works in reality. Say you're at the store buying 4 notebooks for $6. Step 1 is finding that unit price, right? So 6 divided by 4 gives us 1.5. Step 2, we write our equation. Total cost equals 1.5 times n, which is the number of notebooks. From there, it's super easy to confidently apply this logic to things like percent discounts, like figuring out that a 20% discount on a $40 item saves you $8, dropping the sale price down to $32. It's just step-by-step logic building. All right, let's test that logic real quick. I want you to imagine that 5 pounds of apples cost you $8.75. Based on the steps we literally just walked through, what is the foundational cost per pound? It's exactly $1.75. Getting kids to find that foundational unit rate is totally essential before they can move forward. Now, let's look at a really common student misconception that acts like a massive crack in our foundation. Picture a graph in your head. It's a perfectly straight line, but it crosses the y-axis at 3 instead of 0. Is this proportional? Take a second to think back to that definition we covered earlier. The answer is a definitive, absolute no. If a proportional graph doesn't pass right through the origin at 0, 0, our whole foundation is off. I mean, no matter how straight that line is, if it crosses at 3, it is simply not a proportional relationship. Recognizing this visual rule is a mandatory check before we can clear a student for the next level of construction. Section 3, defining the math boundary. So we've got to draw a really hard line between 2 distinct zones here. Core Grade 7 is all about mastering proportional reasoning, rational numbers, geometry, and statistics. On the flip side, Algebra I enrichment introduces linear relationships, systems of equations, exponentials, quadratics, and polynomials. The source material is super explicit about this. Algebra I enrichment is great for challenging ready students, but it should never, ever replace the core foundations. Slipping enrichment into core materials without warning, that is a major structural hazard. To prevent those hazards, the curriculum mandates very clear warning signs. Basically, any material built above the core has to be explicitly labeled, whether it says enrichment, an Algebra 1 extension, or an optional challenge. It needs to be there. This stops anyone from accidentally wandering into the high-rise construction zone before they've completely finished their groundwork. Think of this as the final safety inspection. Before assigning any of that enrichment, teachers and parents really need to run through this checklist. Can the student solve multi-step equations? Can they interpret linear graphs? Can they use rational numbers accurately? And critically, can they explain their reasoning clearly? If they check all those boxes, okay, their foundation is rock solid.
Section 4. Algebra 1 enrichment units.
Now, for the students who are genuinely ready to build upward, the pacing guide has a very rigorous timeline. It kicks off with a 6-week unit on relationships, followed by 7-week blocks dedicated to linear relationships, advanced functions, and data analysis. It's incredibly methodical. They don't just dive in headfirst, they align the overview with basic level knowledge before turning up the heat.
So these first 3 units, they're basically the lower floors of our skyscraper. Students ascend pretty rapidly from basic multi-step inequalities and formulas in Unit 1, right up through slope-intercepts and systems of equations in Unit 2. And by Unit 3, the complexity just scales incredibly fast, demanding they navigate exponential relationships, radical expressions, and even rational equations.
Section 5. Advanced Functions and Data.
Now we're up in the penthouse, top floors. Unit 4 challenges students with advanced functions, factoring trinomials, and mastering the quadratic formula. And finally, Unit 5 brings the entire structure together. Students take a step back and use scatter plots, two-way tables, and correlation data to mathematically model the real world at an incredibly advanced level. They are essentially topping off their mathematical skyscraper.
So as we step back and look at the entire curriculum blueprint we've explored today, I really want to leave you with this one thought. By strictly separating that grade 7 core from Algebra 1 enrichment, we are protecting the learning process. But the ultimate challenge for educators is this. How do we ensure we're building strong mathematical architects for the future without ever sacrificing that foundational bedrock? It takes immense discipline, crystal clear boundaries, and a step-by-step commitment to the blueprint. Thanks for joining me on this explainer, and I hope this helps you see the architecture of math in a totally new way.